Everybody's sick. I don't mean mentally. I mean the coughing, sneezing, feverish, achy kind of sick. My mom, my dad, my friends, my coworkers, and they're all getting each other sick, and they're all trying to get me sick, sitting down next to me, talking to me, sneezing at me. It's horrible. But it's not working. I'm not sick. I hardly ever get sick, actually. Obviously, my immune system rocks. So since it's taking such good care of me, I figured it's only fair if I figured out how exactly it did that. So, if you want to learn something about your immune system, I'm sure it works an awful lot like mine, even if it's not as good. You just keep watching. If you want to just assume I'm some genetically superior super person or a robot of some kind, you should probably stop watching now. The immune system works basically by recognizing things in your body that are not part of your body. All the cells in your body display a special kind of marker, like a home team jersey, and anything that doesn't have that attracts the attention of the immune system. And these things are called antigens. Sometimes the immune system gets a little confused and starts attacking the body it's supposed to be defending. That's what happens in autoimmune diseases like multiple sclerosis, lupus, some kinds of arthritis, and type 1 diabetes. Sometimes the immune system gets a little carried away and attacks harmless substances. That's what happens with allergies. Something, in my opinion, that is just a consequence of a strong immune system. There are two types of fluid systems in the body that carry the pieces of your immune system around. Some blood actually has antigens in it attached to the sticky goo on red blood cells. This is how you get blood type. A blood has A antigens and antibodies for B. Type B blood has B antigens and antibodies for B. Type AB has both antigens and no antibodies, and type O has no antigens and antibodies for both A and B. So someone with blood type A, if they get blood type B in them, their immune system is going to attack the B antibodies on the B blood. But someone with type O, who has antibodies to both types, can only receive type O blood, but they can donate to anybody since they don't have either antigen. Someone with type AB can receive blood from anybody since they don't have either antibody, but they can only give blood to type AB since they have both antigens. The other fluid system is the lymphatic system. This is a clear fluid with less proteins than blood, so it's less reactive to the immune system. It's also acidic and coats your organs, which helps keep out invaders that would like a higher pH level. The lymph nodes, which are located a lot around your neck and your armpits and a couple other places, act as filters for the immune system. They clean out like defeated antigens, dead immune cells, and whatnot. They're also a congregation point when there's an infection. So when you're sick, they get busier and swollen like a freeway at rush hour. Macrophages and dendritic cells are antigen-presenting cells. They basically pick up the antigens and take them throughout the immune system to show the other pieces of the system what the invaders look like. Macrophages congregate in different areas of the body depending on type. Some of them move freely throughout your system. They pretty much swallow up the antigens whole, tear them apart, and wear their pieces on their outside so the immune system can see what the invaders look like. Dendritic cells look a little like nerve cell dendrites with lots of little fibers hanging off them. They basically grab the antigens and take them throughout the immune system whole so that the other cells can see what the invaders look like. One type of dendritic cell hangs out in your naughty places, so this can help in the transmission of HIV through sexual contact. The more active parts of the immune system include T and B cells. In order for them to activate, they have to recognize the antigen, basically by being able to fit it to one of their receptors. We inherit T and B cells from our mothers based on what our mothers were exposed to. We also make T and B cells in random configurations in huge numbers. So even if there's something completely new to our system, there is a good possibility that at least one of these cells will be able to fit with it and recognize it. Once the cell does recognize it, then it starts making copies of itself. Some of these copies are just designed to keep that template, that fit. So the next time this antigen comes up, the whole immune system will start up faster. So that way, if you've been exposed to something before, your immune system starts up faster and you will probably wipe it out before it even starts to bother you. But they also make active copies of themselves, designed to attack the antigen. Helper T cells also are made in this process, and they run around basically telling the killer T cells and the B cells that it's time to wake up and start going to work. B cells, which make up about a fifth of all of these cells, go around and tag the antigen. They put like a little molecular structure on it so that the complementary immune system releases enzymes that can damage the antigen, or at least make it easier for other cells like the macrophages to kill it. The little tag also has the added bonus of sort of messing with the antigen's work so that it really can attach to other cells and damage them. The killer T cells, which I'm sure most of us are all very familiar with, having grown up in the AIDS generation, those basically go around and kill infected body cells. So that sort of starves out the antigens. So these killer T cells actually fight infection by killing off your own body's cells. That's not something that you would want to continue for very long. You wouldn't have much left. So there is another type of T cell that when it no longer sees antigens around, it tells the other cells to shut down. And the fewer antigens that are there, the more the suppressor cells start saying shut down. So the system gradually subsides. So you can see it's a very complicated system, and this has been an extremely simplified explanation. But at least now I know why I'm not getting the cold that everyone has, and why I don't get sick that often. Obviously, my random configurations for my T and B cells are a little closer to what's actually out there. So maybe I just got lucky. Or maybe I've just had this cold before, so I'm immune.